Okay, let us discussion about the suppose the given function y is equal to f means the given not only function you can say that s it is a function uh, is given y is equal to f of x. Let us assume that there is no curve and all those things. It is a smooth curve, and I want to work out. I can say that what is the value of the function near the zero. As I told you, we can take an enclosed interval 0 comma x where x is very close to that one. We can apply the maclurin series. We are going to find out based on that we can whenever we are going to express the function at x, because yeah, if you bring x is equal to very close to 0, the highest degree terms x cube, x raised to x square, x cube, they have become negligible. The lowest degree term will going to say that what is the curve behavior. At the same thing they are telling the lowest degree terms. The maclaurin series is a way to return the function as a sum of powers at around x is equal to 0. This is maclaurin series. Here, by just telling the Maclaurin series is not, it is not directly give the value of the function here to the. If you bring x is very close to the 0, then whatever this x square, x cube, they become 0. Then we can say that the lowest degree term is going to gives the curve behavior at the origin. So that what we can do directly write down the Maclaurin series for f of x and find out the lowest degree terms, and the lowest degree terms will tell that term will shows how the curve behave. For example, f of x is equal to sin x. If you expand around the function by using Maclaurin series, the lowest degree term is x here. This will going to give directly will give curve behavior as x approaching 0 x point like that directly it gives by x value itself. Thus the curve behaves like a straight line here. Okay, this is how we can, but the question is it possible any alternative is there way is there? Yes, we can use alternative way. What we can say, if you say sometimes the maclaurin, I can simply rearrange the equation in order to power ups, then look the lowest degree terms. This term will show the curve behavior near the origin. When x is very close to the 0, the powers of x, the x cube becomes much smaller. Therefore, so that lowest degree term dominates the value of this near this that region only. The I can say that will give but orders of the power. Now, can you verify directly? Suppose if of x is equal to the given 3x square 5 into x raised to 4 5 7x raised to 5 is the given. The lowest degree term is 3x square. Therefore, the near the origin, the function f of x acts as a 3x square. Okay, but the same thing can be obtained by Maclaurin series. For example, what we can say by Maclaurin series also, same thing you can get it. By Maclaurin series, the function is written like this: f of x is equal to f of 0 plus f dash of 0. And if you work out f of x is this one, f of 0 is 0 here, and f dash of 0 is nothing but the 0, because why f dash of 0 is 0? Because again it becomes f dash of x is equal to 6x, and if you f dash of 0 is 0, then f double dash of x is 6 into 6 plus lowest plus 60x square plus 140x cube. The lowest degree term is, I can say that 6. As I told you, the first non-zero derivative, the lowest, the first non-zero derivative is nothing but the f dash of 0 into divided by 2 factorial into x square, that is 6 into x square divided by 2, that is equal to 3x square. Though the exactly same result as the shortcut method. Therefore, the both the methods will going to give. The Maclaurin's explains the expansion around the near the 0. Whenever I can say that there becomes x square and all those things, the first non-degree highest degree term is going to come. If suppose a1 is 0, next you can go to the this one. Okay, now if I want to find out the curve behavior, not origin, some point x is equal to h, then you can use Taylor's expansion. Suppose I want to find out the function x is equal to h, some around that. You can say that by formula we can know that by Taylor's expansion f of x is equal to f of h plus f dash of h into x minus h. Like this, we are going to find out. Whenever x is very close to the h, this x minus h and all those things work. Just like maclaurin series, the lowest degree non-zero term will going to dominate the behavior of the curve near the x is equal to h. But again here shortcut method, in the if you rewrite the function in terms of by capital X is equal to x minus h, okay, in the expand the power means if the given function is f of x is equal to x minus 2 whole square plus 5 into x minus 2 whole raised to 4, by just I want to find out the x value, I want to find out what is the function behavior whenever x is very close to the 2. You take h is equal to capital X is equal to x minus 2. Whenever x is very close to the 2, then whatever capital X is small, and therefore we can rewrite this function as capital X square 5, and the lowest degree term is x squared. Means I can say that this x is equal near x is equal to 2, they can say that f of x is equal to act as x minus 2. The whether we use Taylor's or just expand the function in the power of x minus h and lowest degree term gives the main behavior of the curve. The both the methods give the same result. Okay, this is how the understanding the point. But here we want to find out x is very close to the 2, means I can say that we can take capital X is equal to x minus 2 and arrange it, and this becomes like this. Whenever x is very the x is very close to this this x raised to 4 is becomes negligible, like, therefore it will function act as a capital X square near to the origin, means capital X square means f of x acts by substitution back x minus 2 whole square. But the same thing, by applying these things you can same result. Okay, you can get it. Okay, let us check with again Taylor's expansion. You can by Taylor's expansion you can read this one as um, we want to find out f of x very near to the h, that is Taylor's f of 2 plus f dash of 2 x minus 2, like this, f double dash of 2 that but what I want to say that the given function is f of x is equal to x minus 2 whole square plus 5 into x minus 2 whole raised to 4. Then we are going to find out f of 2 that is equal to 0, and f dash of x we can get like this, 0, and f double dash of x we can get 0. Whatever the Taylor's expansion is, first is f dash of 2, this one f, sorry, f double dash of 2, this we going to give first non-zero term, therefore we can say that this is f of f dash of 2 is what, that is 2 divided by 2 factorial, the becomes lowest degree terms become x minus 2 whole square. This is how you can same result what we are by using that also, and both the shortcut methods and maclaurin series you can get same thing. This is how you can understand the things. Okay, thank you.